Hello friends, welcome to my YouTube channel Engineering Modules. So friends, today I am going to discuss about Norton's theorem. In my previous video, I discussed about Thevenin's theorem, which is the part of network theorem. So now I discuss about Norton's theorem. So at first, I state the statement of Norton's theorem. So Norton's theorem states that a linear bilateral DC circuit consisting a current or voltage source can be replaced by a equivalent circuit that contains a current source and a parallel resistance. So we come to know that a total complete circuit with consisting a current or voltage source can be replaced by a equivalent circuit that contains a current source and parallel resistance. In Thevenin's theorem, we see that Thevenin's theorem is dependent on voltage source, and Norton's theorem we see that it is dependent upon current source. So now we explain this Norton's theorem more precisely. So let's start. So friends, this is a bilateral linear DC circuit which contains a voltage source. It also may be connected with a current source. This not differs. So we need to convert this into Norton's equivalent circuit. So the first step is to short the load resistance and find the short circuit current. So for Norton's equivalent circuit conversion, we first short the load resistance. This is short circuit, and we need to find the current through this branch. This is short circuit branch. So at first we calculate the total current through all the circuit, and then we need to divide the current. This current is come from this is the total current, and divided into two branches. This is the short circuit branch. So we need to calculate this short circuit branch from the total current. So now let's calculate. So this is the total current through the circuit. Rx is series with this parallel branch, Ry into Rz plus divided by Ry plus Rz. So this is the total current, and the short circuit current is divided from this branch. So from current divider rule, we know that the total current into the opposite resistance is Ry divided by the total resistance. So this is the short circuit current. So this is the first step. Now we calculate the resistance through the circuit to replace all the sources by their internal resistances. So let's calculate. So in the video of Thevenin's theorem, I state that in the change of any source by their internal resistance, voltage source will be short circuited and current source will be open circuited. So this is voltage source, so it is short circuited. So the equivalent resistance through the circuit is Rz plus Rx into Ry divided by Rx plus Ry, because Rx and Ry are in parallel and Rz is series with this parallel branch. So this is the R equivalent. So now we go to draw the Norton's equivalent circuit, which consists this equivalent resistance with parallel with a current source. This is short circuited current source. So now draw the circuit. So in the step 3 we draw the Norton's equivalent circuit. This is the short circuit current source. The value of this is the ISC Vs by Rx plus Rz Ry divided by Rz plus Ry into Ry Rz plus Ry. So, and the equivalent resistance are in parallel to the current source, and our load resistance is also parallel. So this is the Norton's equivalent circuit. So now calculate the current through the load resistance. So the load resistance current is, so this is the current through the load resistance, because the ISC total short circuit current is divided through R equivalent and R load. So this is the current through load resistance. This is ISC into R equivalent, the opposite resistance, divided by R equivalent plus R load. So this is the current through load resistance. So friends, this is all about Norton's theorem. We know that from this video that what is short circuit current, what is total current, what is Norton's equivalent circuit, what is equivalent resistance when all the sources are replaced by their internal resistances, and what is the load current. So this is all about Norton's theorem, friends. In my other videos, I am going to discuss about the left network theorems, and also discussed some numerical problems on Norton's theorem, Thevenin's theorem, and all the extra theorems. So friends, keep watching and please like, share and subscribe my channel. And for today, thank you.